This week, we're going to learn how to multiply and divide radicals. Number one, square root of 3 times the square root of 3. Now, if you remember, you can take square roots and you can divide them. If whatever's under the square root has factors, you can write it as factors. And then you can also combine it back together. So this is also true. Actually, let me write that in a different color. This is also true of this problem. Then what does that mean? The square root of 3 times 3, the square root of 3 squared, well, that's just 3. We know that. So that's how you would solve that. So whenever you see the square root of something times the same thing, square root of something like that, then that means it's just going to be whatever's under the square root. That's your answer. Number 2, square root of 15 times the square root of 15. How about you give this one a try? Same thing. Square root of 15 squared is just simply 15. The square root and the squared cancel each other out. Number 3, 2 times the square root of 10 times the square root of 10. Now for this one, you have a 1 in front of here. It's invisible. So you're going to multiply what's on the outside of the square roots first, which is 2 times 1 is 2, and then what's on the inside of the square roots together as well, like that. So what you have here is 2 times the square root of 10 squared, which is just going to simplify to 2 times 10, which is 20. This became 10 right there. Number 4. number 4 is the square root of 3 times 4 times the square root of 12. Move this up a little. Why don't you try that? Well, you can take what's in the square roots, multiply those together, and then what's on outside, 1 times 4 is 4, and then 3 times 12 is 36. 4 square roots of 36. Well, the square root of 36, you always ask yourself, is it a perfect square? And in fact, it is. So we're going to have to take that square root. What is the square root of 36? 6. So our answer is going to be 4 times 6, which is 24. That's our answer. Okay, number 5. The square root of 15 times the square root of 10. Okay, why don't you try? So this one is solved the same way that the other ones were. So what's 15 times 10? Well, 15 times 1 is 15, you add a 0, so 150. Square root of 150. Now, 150, as we know, is not a perfect square, if you look at your chart. So what perfect square goes into it? Well, that would be 25. 25 times 6. And then you take the square root of 25. And you got 5 from that. 5. Square roots of 6. Because you can't simplify square root of 6 anymore. So there's your answer. Okay. So we're going to move on here to dividing now. How do you divide radicals? Well, just like this. First question. Actually, I'm going to go number 6, just continuing. 5 square roots of 2 divided by the square root of 5. Now, with dividing, you have to follow this rule, okay? Whatever you get for your answer cannot have a square root in the denominator, okay? So you all see this? See that? See that square root symbol there under the fraction bar? That's illegal. You can't have that. So what we're going to have to do is do something to get rid of it. Now, with fractions, you remember that I can multiply the same number on top and bottom, And that's the same as multiplying this thing by 1. It doesn't change the value, but it does change the way it looks. And so we're trying to get rid of this square root symbol, and that would be a great way to do it, is multiply the top and bottom by something. Now, what something are we going to use here? What something are we going to use? Well, watch the trick, okay? Whatever you have in your denominator, and it has a square root over it, you're going to take that, okay? Watch this. Here's the trick. You multiply that, this whole thing, by the denominator over itself. Okay, so you see how the square root of 5 right there, take that, multiply this whole thing by square root of 5 over square root of 5. So that's the trick. And you're probably wondering why. Some of you may see it, some of you may not, but keep watching. When we multiply fractions, we multiply the tops and then the bottoms. So let's do that. 5, and some of you may see it now. 5 times 1 is just 5. 2 times 5 is 10, so square root of 10 right there. That's on top. And then on bottom, we've got a square root of 5 times a square root of 5. Okay, well that's interesting. Remember what that is? It's just 5. So that allows us to eliminate the square root, the radical sign in the denominator. So we have 5 square root of 10 over 5. But this answer is not as simple as it can be yet. Why? Because we have matching factors on top and bottom. What is that factor? It's a 5. So because of that, we can cancel the 5s. So we're left with basically 1 times the square root of 10 over 1, which is simply just the square root of 10. We don't need to write 1 here and 1 on the bottom there. There's our answer, square root of 10. All right, let's do another one here. Let's do number, what are we on, number 7 now? Yeah, number 7. It's going to be 3 square roots of 4 over the square root of 12. Why don't you try this one on your own? Okay, now you're probably realizing that, hey, I know the square root of 4, that's 2. Okay, great. Let's write that then. So we got 3 times 2 on the top here. This is just 2. So that means 6 on top, 3 times 2, right? And then you got the square root of 12 on the bottom. Now remember the trick? If you have a square root on the bottom, that means you're going to have to multiply the top and the bottom of this fraction here by this, okay? The whole thing. So we're going to take the square root of 12, multiply it on top, and then we're going to multiply it on bottom. And that's going to eliminate the square root on the bottom, right? Because when we multiply fractions, multiply tops and bottoms. 6 root 12 over 12. Now, we have this square root of 12, which actually has a perfect square in it. Okay, so we have to keep simplifying it as much as possible. What's that perfect square that's inside 12? Well, it's 4. 6 times the square root of 4 times the square root of 3 over 12. So 6 times the square root of 4, well, that's 6 times 2, right? 6 times 2 times the square root of 3 over 12. That gives us 12 square roots of 3 over 12. And then finally, the 12s cancel, right? Matching factors on top and bottom. And all you're left with is the square root of 3. That's as simple as it gets. That whole thing just simply equals the square root of 3. All right, one more here. Number 8. We have 3 times the square root of 5 over the square root of 3. Try this one on your own, please. Okay, so we got to get rid of this radical in the denominator. So remember the trick. We take that, we multiply this whole fraction by that square root of 3 over the square root of 3. This, you guys, right here, what is this equal to? Anything over itself is 1. So because of that, this thing does not change as far as the value. It just changes the way it looks, which is what we want. All right, so 3 times the square root of 5 times the square root of 3 over the square root of 3 times the square root of 3 eliminates the square root symbol. And we've got 3 square roots of what? 5 times 3 is 15. And then 3 times 3 is 3. 3 times 3 is 9, excuse me, but square root of 3 times square root of 3 removes the radical, and then we cancel out the 3's. So we're left with the square root of 15. It doesn't simplify, so we're done. Multiplying and dividing radicals.